welcome to the deep dive. Today, we're plunging into a topic that's, well, it's incredibly exciting, but also really challenging. The amazing promise of gene therapies.
Absolutely. I mean, think about it. A single treatment that could offer long-term benefits, maybe even a cure for some really tough conditions.
That's the dream, isn't it? These innovations are phenomenal. But, and this is a big but, they come with these monumental upfront costs.
Huge costs.
Okay, let's unpack this. How does a massive healthcare organization, say like Medicaid, even begin to manage paying for a single treatment that costs millions of dollars right now, even if the benefits stretch way into the future?
And that's the core issue. This raises an important question. How do we actually figure out the long-term financial impact of that kind of upfront investment?
Right.
So our deep dive today is all about exploring that. We're looking at a specific study, a recent one, focusing on what are called value-based contracts, VBCs, for cell and gene therapies, specifically within Medicaid.
Value-based contracts.
Yeah.
So paying for results.
Essentially, yes. Tying the payment to how well the therapy actually works over time rather than just a massive check up front. It's about managing that risk. And critically, this study used real-world data.
Not just theory.
Exactly. Real spending data. They specifically looked at treatments for hemophilia A and B to really, get into the details.
Okay, so real data versus the estimates, and I bet there was a difference. Here's where it gets really interesting. This study apparently found a major gap between those theoretical cost estimates you often see, in the medical literature, and what Medicaid was actually spending.
A significant gap.
We're talking about therapies like the one for hemophilia A, priced around, what, $2.9 million?
Roughly, yes. And hemophilia B is even higher, about $3.5 million for one treatment.
Wow. So what did the real-world data show about the costs before these new therapies, the standard care?
Well, this is fascinating. The literature, the estimates, suggested managing hemophilia A cost about $633,000 a year, and for hemophilia B, around $689,000 annually.
Okay, pretty high numbers.
Yeah, very high. But then they looked at Colorado Medicaid's actual spending records, real-world data, and it showed average annual costs of $426,000 for hemophilia A.
Well, that's much lower.
And $546,000 for hemophilia B, still high, but significantly less than the literature suggested.
So the estimates were way off.
Here's the aha moment. Those super high literature estimates, they weren't representative of the average patient. They actually only matched the spending for the top 5% of hemophilia A patients and the top 13% of hemophilia B patients, the ones with the absolute highest costs.
So the models were based on the most expensive outliers, not the typical patient.
Pretty much. It's like basing your entire city's budget on the cost of maintaining only the most complex, high-maintenance infrastructure projects. It skews the whole picture.
That's a huge difference. And it must completely change the calculation for when these new therapies actually save money, the break-even time.
Exactly. If the ongoing costs you're saving are lower than you thought, it takes longer to recoup that huge upfront investment in the gene therapy.
So the literature suggested, what, about 5 years to break even?
Around that, yes. But using the real-world spending data, that break-even time jumped to approximately 8 years for hemophilia A.
8 years.
And about 6 years for hemophilia B. So longer than initially projected based on those higher estimates.
That adds a lot more uncertainty for planners, for budget folks at Medicaid.
A lot more uncertainty. The study actually calculated that even after 10 years, the probability of having actually reached that break-home point was only 48% for hemophilia A using real-world costs.
Less than a coin cost.
And only 59% for hemophilia B. Still not a sure thing by any means. A big part of this uncertainty comes from just how much the real-world costs vary from patient to patient.
So it's not just the average that's lower, but the range is wide.
Precisely. The study mentioned substantial variability, somewhere between 83% and 99% of the average cost. That kind of fluctuation makes financial forecasting incredibly difficult.
Okay, so lower average costs, longer break-even, more uncertainty. And then there's another layer, right? Who actually gets the treatment?
Yeah.
The eligibility criteria.
Yes, that turned out to be a really crucial factor. The study looked at how changing the criteria who qualifies for the gene therapy significantly impacts that break-even time.
How so?
Well, for hemophilia A, for example, if you set the bar relatively low, say patients who needed at least 4 standard treatment claims a year, the break-even time stretched out to about 10 years.
Okay.
But if you tighten the criteria, focusing only on the patients needing the most frequent expensive care, like at least 20 claims a year, that break-even time dropped dramatically.
How much?
Down to just 4 years.
Wow. So who you treat fundamentally changes the economics.
It really does. It shows how critical it is to define the target population carefully when thinking about these contracts.
So the practical takeaway here seems pretty clear.
If we connect this to the bigger picture, yes. It highlights that using this kind of detailed, real-world data is absolutely essential for organizations like Medicaid when they negotiate these value-based contracts.
It gives them a much more realistic footing.
Exactly. It helps manage those unpredictable budget swings. It allows them to share the financial risk more fairly with the manufacturers. And crucially, it helps make sure patients can actually get access to these potentially life-altering therapies in a way the system can sustain.
It really underscores that tension, doesn't it?
Yeah.
This incredible, life-changing medical innovation bumping up against the hard financial realities of healthcare systems. Finding that balance.
It's the central challenge. And this deep dive really shows how getting granular, understanding the actual real-world costs, and how patient eligibility plays into it is just paramount for making these groundbreaking treatments sustainable. It's not just about the list price, it's about the true value and cost over time in the real world.
So, a final thought for you listening. How could these insights, using real-world data to negotiate contracts for these super expensive therapies, apply elsewhere? Think about other high-cost medical treatments or maybe even totally different fields dealing with big, long-term investments where the outcomes aren't certain. It really makes you think about the power of data to cut through the noise, doesn't it?